Let's get started. Welcome back. So if you go to the course website and you hit this, bloop, we'll have homework 3, yay. So we're starting homework 3 content today. I know, as things go, most of you are probably thinking homework 2. Homework 2 is on your mind. But I'm thinking homework 3, so I'm going to start teaching homework 3. Did you? Nice. Question. I can't hear you. I still can't hear. Hey, everybody, shut up. I vaguely heard it. The Go Bills is all I need to know, though. Chiefs suck. Boo. No, they don't. That's why the win tastes so good. Oh. All right, let's get going. Y'all are pretty chatty today. Everything's just a jumbled mess of sound in my head. So we're going to start homework 3 content. I'll need an example by the end of lecture of a website that uses WebSockets. So if anybody knows a website that uses WebSockets, hit me up in the chat, and I'll use that for the lecture example. By default, I always end up at Twitch, so I kind of just want to go to a different site if anybody has one. So WebSockets. ProducePong.com. I might go to ProducePong.com. All right. So last time we talked about Ajax real quick, and said that this was a way to be able to have the server send information to the client. We saw Ajax is going to be a request that is sent after the page loads. We have some JavaScript that's going to send a request to the server. We get a response and then process that information, render it to the page, whatever we're going to do with it. And then we started using polling, and we talked about polling and long polling to be able to get ways to get continuous information from the server. Polling was just sending the request at regular intervals, say every 1 second we send a polling request and through Ajax, and then the server will respond with any new information that we need to know about. So every second we would get our updates, and we'd have a little bit of delay, but a lot of network traffic. I got a little bit, I won't say trouble, but messed up a little bit with polling one time. I had a chat app example I was showing in 115, I think it was, and I opened it to the class. I said, here's the chat app. It was deployed on my DigitalOcean droplet, and I said, use this chat app. It uses polling, and we talked about polling in 115 at that time. And it was a class of, I don't know, I want to say there were 100 students in the room, and maybe 50 of them actually went to the website and were chatting all kinds of dumb things and stuff. And I was using polling at 1 second intervals. And it went down, the site crashed, and I'm like, oh, come on, my stuff isn't working, this is embarrassing. And then I got an email from DigitalOcean saying, hey, we detected a DDoS attack. Don't worry, we got you. We blocked everybody from UB. Their IPs can't access your server anymore because they were trying to attack you. You're welcome. And I'm like, oh, DDoS attack, what the hell? And then I did the math. I'm like, 50 students, 1 request per second, times an hour, and then longer if they didn't close their browser after class. Like, it's a lot of requests. There's a lot of requests being sent. I can't do math anymore, but 50 students times 60 per minute times, we'll say an hour, 60 minutes. It's 180,000 requests that were hitting my server over the course of an hour. So polling, not the best thing. It's a lot of network traffic, and if you have something, some kind of DDoS protection in place, it's probably going to kick off when you have a lot of requests like that. It can potentially, it did for me. DigitalOcean's like, no, I'm going to protect you from UB because clearly a lot of students are attacking you. I'm like, no, it was me. I DDoSed it. I told them to. It's fine. But it ruined the lecture example. So polling's not great. Replacement is long polling, which can get that number down quite a bit. By sending requests like polling, by having them hang for a while, usually at roughly 15-second intervals, And then if over that 15 seconds the server has new information to send, it'll respond, and then you open up a new long polling request. Much more efficient, but a little bit more complex to build. I should say a lot more complex to build because polling's pretty trivial. You just set interval and choose your polling interval. Long polling, a bit trickier, a bit more complex, but so much more efficient. So if you're going to use any type of polling in industry, it's going to be long polling, I would hope. I would hope you wouldn't see regular polling. But we still have some issues with that, and I shouldn't say that. Long polling's not bad. It has a bit of overhead because it's a new HTTP request for each piece of communication. It's not bad depending on what your app is. You wouldn't do anything live. You wouldn't do like live gaming where you're trying to react at 60 FPS with long polling. But it's not bad. It'll get you through a chat app for sure. Yeah.
Those intervals, was that saying the client is going to request every second or the server is going to send every second?
Request. Gotcha. Yeah, with polling, it's a request every second. So there's some JavaScript on the page. The page loads, the JavaScript runs, and just fires off a request every second. Even if the server doesn't have any new information, it's going to respond to that request every single second. So our solution that we're actually going to use in this class is WebSockets. This is what Homework 3 is mostly about. By the end of Homework 3, you'll do a little bit of WebRTC stuff, but WebSockets is the main focus of Homework 3. It's really the WebSocket homework. Even WebRTC, you're going to build using your WebSocket code and your WebSocket connections. So WebSockets is really ingenious. It's elegant. I really like WebSockets personally. So what WebSockets does is says, look it, with HTTP, we created a TCP socket connection, right? That socket is a two-way communication protocol that we can reliably transfer bytes to each other. With HTTP, we send a request, get a response, and then for our purposes, we just close the connection, establish a new TCP connection, request, response, and that's what we use it for. WebSocket says, hey man, let's just keep that TCP connection open and just keep talking over it. And that's it. That's what WebSockets are. We want to establish a TCP connection and just use TCP to communicate bidirectional communication. That's what TCP does. HTTP kind of restricts that and says, no, we're going to be a request-response protocol. WebSocket says, forget that. We're just going to be an open line of communication and just leave that connection open and communicate over that connection. And that's it. At its essence, at its core, that's what WebSockets are. Yeah.
With what we're using with now, is every time a request goes to the server, is a new connection opened, then the request goes, and then the connection is shut?
Yes. Yeah, so every time you get a request and send a response, you're severing that connection. You don't have to do that, but I'd say in probably 100% of homework submissions that you'd be doing, and that's what I expect you to do, is have a new TCP connection for every single request and response. Because if you're using Python, most of you found the recommendation using Python, when you hit the end of the, I'm blanking on it, not receive, the handle, thank you. When you hit the end of the handle method, once that stack frame ends, it closes the TCP connection. So if you hit the end of that method, it closes the connection. So if you reach the end of it, you're closing the connection, and the client has to open a new connection to send their next request. Now, you see like keep alive headers. That stuff is saying, hey, we can keep using the same TCP connection for multiple requests and responses. It's just not something I really cover in this class. It's not something I expect you to implement. But when you visit a website, it'll reuse the same TCP connection just for performance. You don't have to do that three-way handshake more times than needed. And key exchange, like we'll see in 3 weeks. Was there a question? I thought I saw a question. Okay. So I like it. It's super elegant. WebSockets is, I kind of think of it as an anti-protocol. It's like, hey, let's just go backwards and go back to regular TCP. We had a really good thing going there. Let's just use that. That's what WebSockets are. So the goal here is to have those push notifications. We want the server to be able to send information to the client unprovoked and without the overhead of long polling. We just want the server at any time to be able to say, here's some data. And that's what we're going to get. We're going to send that data over a TCP connection. This is very efficient, very near optimal way of sending information from the server to the client, and vice versa, as it turns out. So for WebSockets, we establish a TCP connection. We're already doing that. We already do all kinds of TCP stuff. The client is going to send an HTTP request, and that request is going to say, we're going to look at the mechanics of that request today. We're going to do the whole, what we call the WebSocket handshake today. But I'll just an overview of it for now. The client is going to send an HTTP request, and that request is going to say, I want to use this TCP connection for WebSockets. The server is going to say, yeah, okay. And that's our HTTP request and response. So we're building this starting with HTTP. We already have our TCP connection. We have an HTTP request. We're going to send an HTTP response. And that's going to be our WebSocket handshake, which says we're going to keep this connection open and use it as a WebSocket connection. And for the terminology, we say that we're going to upgrade that TCP connection from an HTTP request response to a WebSocket connection. And this is how WebSockets work. That's the overview of exactly how it works. It's an HTTP request that says, yo, let's do WebSockets. The server says, sure, let's do WebSockets. And then you keep the TCP connection open and do WebSockets over that connection. And then we're talking in WebSockets. Yeah.
So the messages that are sent over the still open TCP connection, is a message from the client to the server necessarily like clicking a button or even done by the user, or is it done by the browser?
It could be either, I guess. So when the client sends information to the server over a WebSocket connection, that's what you're asking, right? It can be triggered by anything. At some level, it's got to be in JavaScript. Somewhere there's JavaScript code that sends that information to the server. That code can be executed on a button click or some action by the user, or it can just be in the background with no input from the user. Yeah, it could be both, anything. However you get the JavaScript called. But it has to be through JavaScript. Yeah.
So this is when the server receives a WebSocket HTTP request, is this the upgrade request?
Yes.
Okay.
Yep. So we need to do a handshake. We need a WebSocket handshake because what we want is a guarantee that the client and server are speaking the same language. They're both speaking the WebSocket protocol. So we have a handshake. Just like our TCP handshake, the three-way handshake was, hey, do you speak TCP? Yeah, I speak TCP. And then they can establish a connection after that. We want the same guarantee for WebSockets. You don't want to send a WebSocket request to somebody and think that they speak WebSockets. You think that you have a WebSocket connection, you're sending information over this connection, but the other side just doesn't speak WebSockets or doesn't speak it properly. Maybe the developer made some mistakes or something, or maybe it's not implemented at all. It's not even a feature. So we want to guarantee that both sides are speaking the protocol properly. And for that, we're going to use our WebSocket handshake. This is objective 1 on homework 3, is implementing the handshake, which is built on HTTP. So we're going to receive a GET request with 3 important headers: connection upgrade, upgrade WebSocket. So connection upgrade, hey, can we upgrade this connection? Upgrade, let's upgrade it to the WebSocket protocol. And then the very important one, let's be honest, the only one you're actually going to read in your homework, the other ones you'll just assume are there and you'll be right, is sec WebSocket key. This is going to be some random value, so you're going to have to read it on every WebSocket connection. You're going to have to read this random value from the header. Again, hopefully you have that generic header parsing code, so this isn't any extra work. You just say, give me the value of sec WebSocket key. Grab that value. So you're going to get some random value, and you're going to send a response with our first 100-level response code, a 101, switching protocols. We're switching away from HTTP, switching to WebSockets, and saying this connection is now a WebSocket connection. You're going to say connection upgrade, upgrade WebSocket, the same two headers from before, which you'll just hard code in your response for this. And then sec WebSocket accept with an accept response, which is the bulk of the challenge of this handshake, is computing what that accept response should be, which the next slide I'm going to tell you all about how to do that. Yeah.
This happens once per connection?
Yes, once per connection this will happen. So once the handshake is made, the server and client have a persistent connection with each other over that WebSocket connection, that TCP connection that was upgraded to WebSockets, and they're speaking WebSockets for the rest of the time that TCP connection is open, which could potentially be till the end of time, till one of their hard drives fails or something. So we get a random value here, and we need to send this accept response here. How do we do that? And here's what we got to talk about for a while. This slide is pretty much all of, aside from the headers that we just talked about, which you've messed with headers already. We know how headers work. The bulk of objective one is this one slide. This is your most important slide in this lecture, most important slide in this slide deck. This is how you're going to do the WebSocket handshake. Some very particular steps in this that have to be followed exactly. There are a few libraries you can use. We have to compute a base64 encoding and a SHA-1 hash. You're allowed to use libraries for both of those, so I'm not going to go over like how to implement SHA-1. I think that's a distraction from the course. You can use libraries, whatever you have for those. Python has these both built into the language, right? Yeah. Pull those libraries in, use those algorithms. You don't have to implement those. So what are we going to do? We're going to read that sec WebSocket key. So we got this random value from this header. We're going to read that header and get that random value. It will be random. It'll be different every single time. Even if the same client opens 20 WebSocket connections with you, that value will be different every single time, at least with high probability. It'll be a really long random string. It'll be a string. I shouldn't say thing. But it'll be a very long random string. We want to append to the end of that this. Don't ask me why. This GUID, globally unique ID, this exact number should be hard-coded into your server somewhere. This exact string, as it appears right there, this is part of the spec. The WebSocket RFC has this value in it and says this is the globally unique ID that we're going to use for the WebSocket protocol. You're going to add this exact string, append it to the end of your key that you received. Yes.
Is that like a salt?
No. Yes.
Is this built into the protocol, or is this just for our class?
Protocol. This, when you do your reports for your project and you're looking into your WebSocket library, any library that you use, literally any WebSocket library that you use, somewhere in that library you have to find this value. You'll find that value in there. It is part of the protocol. Every client, every server, everybody using WebSockets is using this exact string. It is not specific to this course. This is the way the world is. Love it. Get used to it. We're going to concatenate that random value with this, take the SHA-1 hash of that, and then base64 encode the hash. And that's your accept header. So why? This is pretty convoluted. It's not super convoluted, but it's strange. Like, why the hell? So why do we want to do this? One, we want to ensure that both sides speak the protocol. This is long and random enough. I mean, it's not literally random, but if somebody sends you the correct accept value, there is effectively a 0% chance that they found that by accident. Like if you get the correct accept, you're guaranteed, all but mathematically, the impossible, probabilities and stuff, all but that, like you're guaranteed that that server actually speaks WebSockets. Like they implemented the if they have this whole thing in SHA-1 and Base64, nobody did that by accident. It can't happen. They speak WebSockets if you get that. You have a guarantee that they speak WebSockets. And it also avoids caching. So the WebSocket key is going to be random and different every single time you open a connection. This is to avoid caching. Sometimes you'll have load balancers or reverse proxies in between the client and your server. You'll have a lot of layers in between that might have very aggressive caching. And if these requests look identical, if you get two requests that look identical and they're GET requests, the load balancers, reverse proxies, CDNs, all this stuff in the middle might cache that and be like, oh, I just saw this request. I saw it. Your server responded with this, so I'm going to respond with the same thing. This is what they responded with last time, so this is what you'll get for a response. Now, if that content is an image, that's fine. That's more performance, you're less load on your server. When that request is an upgrade request for WebSockets, this is bad. We don't like that. We need this request to make it all the way to our server so we can keep that TCP connection open. If this gets cached, if our response, our one-on-one response gets cached, it defeats the whole purpose because we need this request making it to our server so we can keep that TCP connection open. We don't want this being cached, so that's why there's some randomness in this. And we're going to see the WebSocket, the messages that we send over WebSockets to are going to have a lot of randomness to them. Again, to avoid caching, we want to bust that cache. Caching is usually good for performance and everything. With WebSockets, we don't want any caching. So there's quite a bit of randomness involved in the protocol to make sure that doesn't happen. So once we have that connection established, we did the handshake. Then we can move on to Objective 2. I'm not going over the details of Objective 2 until Wednesday. But once that connection is established, we're going to get two-way communication. That's what TCP is. It's two-way communication. We can send bytes to each other. So now we have a two-way communication. This client can send information to the server, which the client could always do that, so that's nothing new. But now the server can send information to the client at will. And that's where things get really powerful. We unlock a lot of potential there. To do that, oh boy, we're going to do some bit parsing. That starts Wednesday. We won't dive into it, but we were seeing the progression of this course. We start out with string parsing. We go to byte parsing. We're going all the way down to bit parsing. And can't really go any lower than that in computer science, at least. So we're going to stop at bits. But it's fun going down the protocols and seeing the progression there. And those bits are going to be masked, which, why do I even mention that here? I don't talk about that in these slides. But masks, we'll talk about what that means on Wednesday. I don't know why I have that bullet point right here. When we do get a frame, on Wednesday we're going to parse this information in this format. This is telling you what each bit means when you receive what we call a WebSocket frame, which is what we call messages sent over a WebSocket connection. We're going to get bits in this information and then look at the location of each bit to extract meaning out of those bits. This thing, all Wednesday, we're going to be staring at this and figuring out exactly what every single bit means on this thing. It's super fun. I have fun doing it. I don't know if anybody else does, but I have fun doing it. Yeah. What do the numbers mean? I got to wait till Wednesday to do that. This is just a foreshadow slide. That we're going to have a specific format. It's going to take me 50 minutes to talk about all of them. And those, I guess, I don't want to talk about masking right now. I should remove these slides from this one. It's a Wednesday topic. But I'll do it really briefly. The The message that's being sent is going to be XORed with some random bits. And that's, again, for randomness. Every message, even if you send the same message 20 times, it's going to look different each time. It's going to be different bits. And that's going to avoid any caching potential. For us, it means more code that you have to write to handle that. Yeah.
Are the frames masked?
The content of the frames, the payload of the frame is masked. The headers are not, or else you wouldn't be able to read anything. On the browser side, this is the code to be able to set up a WebSocket connection. On the browser side, WebSockets are really easy because you're just using your browser. You're saying, hey, browser, I want to send a WebSocket request. And it's going to come up with all the headers, the random key, and all that stuff. To do that, we're going to create a new WebSocket object and store a reference to that socket. This is going to send a request to whatever path you give it. It's going to send a request to that path. That's going to be the switching protocol's request. It's going to be a request to upgrade to WebSockets. The browser is going to generate that random key, set all the headers properly, and send that request to your server at whatever path you specify. For this example, I did /socket. So then in my server code, I'm going to have another elif. I'm going to say elif. It's a GET request for /socket. Then I'm going to go into my WebSocket code. You're going to send it using the WebSocket protocol. And this, I recommend this. This is where you would say localhost :8080. If you want to hard code it, I recommend you get out of that habit right now if you're in that habit at all. I've seen way too many bugs with this, and I've chased this bug down so many times to the point where it's one of the first things I look when I see the symptoms of it, and it's usually the culprit. You could hard code this to localhost :8080/socket. This does the same thing if you're testing locally on your laptop. But if you do this instead, window.location.host is going to get the host that sent you this JavaScript. Like, what page did you visit to get this code? Host is going to be that string, a string for that host, including the host and port. It's going to have that in that variable. If you use this, you're always going to have the right host, unless you're trying to create a WebSocket connection for a third-party host, if that's your use case, which would be kind of strange, but I'm sure there's applications for that. This is going to get whatever your host is. The problem is if you don't do this, you hard code localhost :8080, and you go and deploy at myawesomesite.com. Well, the host is no longer localhost :8080. It's myawesomesite.com. If you just read this variable, you don't have to think about that ever. Just use this variable, and then your host is always set correctly. Whenever I have errors like that, WebSocket can't connect after I deploy, but it works. Oh, it works on my machine. Usually when I'm testing other people's stuff, because I don't make that mistake. I made that mistake enough times. I don't do it anymore. I'll go to the code base, the front end, and I'll just do a search for localhost. And every time I see localhost, I yell at the developer, "Hey, don't hard code localhost. What are you doing? This is insane." Just use this variable, and it gets rid of that issue. You don't have to retype your path every single time you go to deploy, or you change your domain name, or you go back and forth from dev to prod. You don't have to change that if you read this variable. Highly recommended. Get in the habit now. You'll save yourself a lot of frustration. Yeah.
So this goes inside script.js, right?
Yes. Yeah, this is front-end JavaScript. This will be on your front end.
Yeah. So if this is what is checking if the host is correct or not, then how will we serve the JavaScript file before even checking?
So when the JavaScript file is going to be retrieved through an HTTP request, and then when you get that JavaScript, this window location host variable is already going to have that host of where you sent. I believe it's the request for the original HTTP that's going to set this host variable. And then by the time you get the JavaScript and run this JavaScript, that host will already be populated. Socket has an on message, takes a function. Oh, wait. Right here. Takes a function that takes one parameter, which is the payload of the message that the server sent to you. Whenever you receive a message from the server, onMessage is going to be called. I set it equal to render message, takes my message, and for this example, I'm just printing it to the screen. This is where you would render that content to the screen in whatever way your app should do or whatever else you need to do with that information. And then send message, if you want to send a message using a WebSocket, a reference to the WebSocket you created, that's storing a reference to your TCP, not directly, but it contains a reference to your TCP connection. Send, and just give it a string. And your browser is going to do all the formatting for a WebSocket frame. Format this properly. It'll do masking and all the payload length, all the stuff that we're going to talk about on Wednesday. All you do is give this a string. The front end does, your browser does the rest of the work. So this is the usage on the front end. And then the homework, what you'll spend countless hours on, is implementing the back end for this. For the username, do I give that to you? I might. I don't know. I think I give it to you in the homework handout, right? I think it's in there somewhere. For the track and the username. So you would put that code. You would put that code like right here to generate the random username, and then have that sent each time you send the username.
So it's not like an input, right? Like on the root page, whenever you post a message.
I forget 100% what I put on the homework, to be honest. I think I said it can be randomly generated, because I think in homework 4, that's where they create their accounts and choose their own usernames. I think I left it at randomly generated for homework 3. I'm almost positive I did. Oh, I got ahead of my slides here. On message, that's going to take a function that takes one argument, one parameter, and then does whatever you need to do with it. Then send things over to the server. And this is what we'll parse on Wednesday. Okay, so I want to show you this in action. Do we have a... What do these numbers mean? Okay, so we need a site that uses WebSockets. The only thing I saw was producepong.com. So I guess we'll go to producepong.com. So I'm going to go to my... It's a lot of online people. So I'm going to go to the browser console. I've showed this a few times in lecture. I don't know how much I've explained it so far, or how much I should. But I'm going to the browser console. I right-click, go to Inspect Element. And there are other ways to get to it, too. You can go to Developer Tools. Or there's a keyboard shortcut that I always forget what it is. It says it right here, I guess. Option I don't know. I always right-click and do Inspect Element. So that's going to give me my browser console. I'm going to the Network tab so I can see all the HTTP requests and responses. And I'm going to refresh the page, which I don't think they have WebSockets on this page. I'm going to not preserve log. I'm disabling cache too. This is a common issue when you're developing a website. Your browser likes to aggressively cache things as well. If you open this console and disable cache, you'll always get the fresh site from the server. So if you're seeing old stuff, old content when you're testing, try to go into here and disable cache. So I don't think WebSockets are on this page. Let me spectate a game. I
think you need to have the cache on to load things.
This server can't handle the load. Click Nicholas on, right here. I got to enter a game because the game part of it's what uses WebSockets. The home page doesn't. And we wait. Someday, this course is going to require scalability. Someday. It did not last semester where Nicholas and Sia, etc., built this page.
It might be easier to cache off.
I need the, I'm not going to have this in cache at this point anyway.
So click the link that you got in the message.
I thought I already clicked that. Oh, I see.
The most recent one. Yeah.
We need to get to the WebSockets. And we can see, it looks like their chat uses polling, vanilla polling, right? Not long polling?
Yeah, pretty bad.
Which might be why the server slows down. Might be one of the reasons. All right, so now we're in the game. We play Produce Pong. We're here for WebSockets, though. So I see this one request, which is the WebSocket request. I am not ready. You know what? I'll be ready. Press what? Oh, the pressure's on. Oh, I tried to get fancy with it. No, you got to hit it with the side of the paddle, though. There it is. Yeah. All right. All right, so, but the site works. You could all go and play. It's fun. This was built last semester. I think I just mentioned that. This could be you. You could build something awesome like this. So I went to the request that has the 101. If you have trouble, like there's a lot of requests here. If you have trouble finding it, I just sort by status, and the 101 will rise to the top. So I got this WebSocket request. Their URL is pretty gross. Is that a library that generated that?
Yeah, it's classic stock.
Okay. And I'm going to see the headers that I have, the request headers. I'm going to get connection upgrade, upgrade WebSocket, and sec WebSocket key. This is the important one that I need, is this WebSocket key. There we go. So here's my key, and I want to generate my accept from that key. So what I strongly recommend when you're doing the WebSocket handshake, when you're coding this, is go to any site that uses WebSockets, look at the headers of the WebSocket request, let me resize things, I can do this, and get a sample. Where did this come from? Am I blind? Where? I was just there. I'm not on the right request, am I? What did I even do? I lost my request. Oh, because the game ended. Oh. I created curry. I need a sample. Can
Oh, Jesse, you can join a currently running game. You go to scroll down and spectate the games. There's one that's been running for 3 months.
Oh. Yeah, let me spectate that.
What is the logo?
The what?
Right on the orange ones on the gray bar.
Top one?
Yeah.
Got quite the score. Okay, now I should have it. All right, so I'm going to go to my requests. We can do this, we got time. The key is going to be different because this is a new connection, so my old key is no good anymore. Let me increase the size of this. Let me get rid of the formatting there. And then I want to look at the accept that was returned by the server. And what I want to do, you're killing me here. And what I want to do, this is not the smoothest demo. We will get there, though. So I want to get from the top value to the bottom value. Okay. I want to get from the top value to the bottom value by computing based on what we saw in the slides. So let's do this. Preview. I don't memorize this, so I'm going to copy this. WebSocket GUID, I'm just going to search it. WebSocket, Wikipedia should have it. There's my GUID. So I'm going to append this to the end of my value here, and I want to take the SHA-1 hash of that. So one thing that's really important with should I do it the wrong way first? I don't have enough time to do it the wrong way. One thing that's really important is that when you compute the SHA-1, make sure you're using a hex hash algorithm. Make sure you're doing it in hex. If you're getting the output as a string, it's not going to work the way you want it to. So let me get the SHA-1 hash of this. Then I'm going to compute the MD5, not the MD5, Jesus, what am I doing? Base 64, thank you. Base 64 encoder. Destination. Oh, I feel like I'm messing up here. So this is my SHA-1 hash of the concatenation. And then with the SHA-1 hash, converting that to base 64, I want to make sure, this is where I have to make sure it's hex. I had it backwards. I want to make sure I have a base 64 encoder that's going to take hex as an input, not text, and then output my base 64 encoded string. Oh, let me get the equal sign here, which will be exactly the accept. So if we take the SHA-1 hash of that concatenation and then base 64 encode, make sure your base 64 is expecting hex as its input, not a string, then you should get exactly that value. So this is a way that you can test without running your server, especially if you're running in Docker, going to the browser and seeing if you got the correct response from that you got a 101 and everything was fine with the switching protocols. Instead of doing that, go to a site, or Wikipedia has an example as well, and try to just compute, starting with the key, and compute your accept to make sure you're doing it right. I would do it just like I did it first. Make sure you have the right idea that you're doing it right, and then go to your code and write a method or a function that's going to compute that for you, and use that as a test case, and make sure that your code is going to compute the exact thing as well. And then just unit test that function instead of trying to run your whole server and see if it works. If you come to office hours and you're running your server every time and go into the browser to see if it works, that's hard to do, and that's frustrating. If you do that to me, I'm just going to say code up your test case, because it will save you a lot of time. Especially when I'm going to have the same recommendation, and I'll give examples on Friday. I'm going to give the same recommendation for parsing WebSocket frames, and it's going to save you potentially hours, maybe days of time if you code up your test cases and then use those for testing. It's one of the times where I really, really encourage test cases. I know none of y'all test after 116, but this is a case where it will save you tons of time. There are many cases where it'll save you tons of time, but this is definitely one of them. Anybody have questions? The demo didn't go as smooth as I wanted, but we got there. I told you we'd get there. Have a great day. I'll see you all Wednesday.